எனக்கு இவர் ஹெல்ப் பண்ணணும். அந்த காயினே இல்லாமல் எனக்கு டாஸ் பண்ணணும். எது? காயினே இல்லாமல் காயின் டாஸ் பண்ணமா உனக்கு? அப்புறம் இன்னொரு விஷயம், அதை நான் என் பாக்கெட்டில் வைக்க முடியணும், சரியா? பண்ணலாம். Hello people, I am Veda and welcome to Very Random Creations. Today we are asked to create a coin toss but without a coin. To do that, first we need to ask one question.
Why do we toss a coin?
We toss a coin to get a random result, either a head or a tail. The moment we toss the coin alternates between head or tail state. The moment we catch the coin or when the coin hits the ground, the rotation stops and it holds on to either the head state or the tail state. So, now tell me, is it possible to exactly predict with 100% certainty each and every time what state the coin will be?
No.
It is not humanly possible to exactly know what state the coin will be. So, what we do? We take a guess. We take a guess on either it can be a head or it can be a tail. It has 50-50% of being a head state or a tail state. So now, this gave me an idea of why not replicate the same with electrical energy. Since a coin toss is basically a mechanical rotation, why don't we try it with electrical energy? This gave me an idea of using 555. No, not that 555, but this 555. Using this, we are going to make an A-stable multi-vibrator. Yes, you heard me right. We are going to make a vibrator, an A-stable multi-vibrator. And since we are using electrical energy, we can have two LEDs, one for head and one for tail. We can alternate between these two LEDs, and the moment we stop or the moment we press the button, it needs to hold on to either the head state or the tail state.
To make an A-stable multi-vibrator, at minimum we need two resistors, one capacitor and one IC555, and those needs to be connected as shown here. As you can see, pin 8 is connected to VCC and pin 1 is connected to ground. When we power the circuit from pin 3 of the 555, we get a square wave like this, and for each consecutive high, we are going to alternate between the head and tail LEDs. On average, the moment when a coin is tossed, the coin rotates around 10 times per second. So now comes the $1,000,000 question: how to alternate at or more than 10 times per second? To get it to oscillate at 1000 Hz per second, we need to choose the appropriate value of resistor and capacitor. Looks like what we need are 8,200 ohms and 68,000 ohms resistor and 10 nanofarad capacitor to generate a frequency of 1000 Hz. Since a calculator is better at doing math than me, I am opening an inbuilt calculator in Electrical Circuit Studio to calculate the frequency generated by an A-stable multi-vibrator when I use the resistors and capacitors I have. Let's see what's the closest resistor I have. Let's plug in that value. Once we plug in those values, looks like what we are getting is 1053 Hz. Basically, if we used these valued resistors and capacitors, we can make the LED alternate around 1050 times in 1 second. Let's simulate this. Through simulation, we can see that at pin 3, if we use these resistor and capacitor, we'll be getting a square wave like shown here. Okay, we have solved the flipping part. Now, the next part is catching the coin. Let's call another engineer. He goes by the name Kali.
Hello. Hi bro.
Hey, hi brother. I need a favor from you. Basically, I'm building a circuit where it alternates between two states using an A-stable multi-vibrator. Now, when I cut the input, it needs to remember the last state. What can I do for that?
Remember you say. So it needs some memory. You can use a register, but it is used to store bytes of information. You can use something like a flip-flop.
A flip-flop, you say?
Haha bro, I know what flip-flop you are thinking about. In digital electronics, there are 4 types of flip-flops: D, JK, SR and T. You may use either one of these for your circuit.
Oh, interesting. There are 3 types of flip-flop. Okay, thanks for the information. Let me study about it.
Many hours later.
Okay, after chatting with GPTs, looks like what we need is a T flip-flop. The flipping part is taken care by this A-stable multi-vibrator, while the catching part is taken care by this D flip-flop. Now, let's build the same in Electrical Circuit Studio. This is the A-stable multi-vibrator using which we'll be getting a square wave, and that will be given as an output in pin 3. This clock output is given as an input to this D flip-flop in clock pin. The D flip-flop has two outputs, Q and Q dash. One of the output from Q is given as an input to an XOR gate, while the other is always kept as high. And the output from the XOR gate is given as an input to the D pin in the D flip-flop. This together forms the T flip-flop, in other words toggle flip-flop. We have connected two LEDs to the Q and Q dash outputs. So basically, when we power this circuit, the LEDs needs to alternate between Q and Q dash as long as the clock input is there, and when we remove the clock output from the IC555, it needs to hold to the last state. Awesome, it works! Okay, theory is done.
Theory will take you only so far.
Now let's build it. This is the voltage divider circuit, and I'm using it to provide 6 volt input to this breadboard connections. I'm using a 9 volt battery to power this whole circuit. This is the IC555 and this is XOR gate and the D flip-flop. This together forms a toggle flip-flop. Here I'm using two LEDs, red and green, where one for head and another for tail. At first I'll be using 1 microfarad capacitor so that we have a frequency of 10 Hz. Now let's power the circuit. Once we power the circuit, we can see that the LED red and green keeps alternating at a frequency approximately of 10 Hz. Now let's try with a capacitor of even lower capacitance. This is a 1 nanofarad capacitor, in other words 0.001 microfarad capacitor. Once we use this capacitor, it needs to alternate the LEDs at around 1000 times in 1 second. Here you can see both the LEDs are glowing. Basically that means it is oscillating so faster that we are not able to see it with naked eyes. If we have a very slow motion camera, we could probably shoot it at 2000 frames per second and then be able to see the oscillation of 1000 times in slow motion. Cool, it works.
Flashback.
அப்புறம் இன்னொரு விஷயம், அதை நான் என் பாக்கெட்டில் வைக்க முடியணும், சரியா?
Testing is done. Now let's build a prototype. The first step is creating the schematics. To do that, I am utilizing the software called ECEDA. It's an open source PCB designing software. Once the schematics is done, I am converting it into a PCB layout. Here, I have set the grid size as 2.54 mm to match the perf board dimensions. We can play around with the positioning of the components and use the auto route feature to create a layout. And once the layout is done, I am exporting the same as in PDF, which then is taken as a printout in 1:1 ratio. Now, let's transfer the trace to the perf board. Here, I am using copper tapes to create the trace. Once the copper tapes are pasted on the perf board, the corners and joints needs to be soldered in order to maintain continuity. And finally, we need to assemble the components onto the perf board and solder them. Once all the components are soldered, I am using a multimeter to check the continuity of the circuit. Here, IC7486 is the XOR gate and IC7474 is the D flip-flop, while IC555 is used to make the A-stable multi-vibrator. Circuit is done. Now let's 3D print an enclosure. So, to create an enclosure, first I have modeled a two-part system, one base and one top plate, and I have given an interesting pattern in the top plate so that I can make it look like a toy. I am slicing the file and looks like it's going to take some 6 hours to print.
Now, let's transfer the file from the computer to the SD card and the SD card to the 3D printer.
Now, I'm selecting the file and starting the printing process. As you can see, I have preheated the bed so that the printing is gonna start right away.
Many hours later.
மச்சான் ஹைடா. ஹேய் ஹைடா. வா மச்சான் ஹைடா. மச்சான் அன்றைக்கி அந்த காயினே இல்லாமல் காயின் டாஸ் பண்ண சொல்லியிருந்தேன்ல, ரெடியா அது? ரெடி மச்சான். பச்சை தொப்பி அதை கொஞ்சம் பாஸ் பண்ண. அதுதான் அந்த டேபிள் மேலே இருக்குல்ல கருப்பு கலரில், அதை கொஞ்சம் பாஸ் பண்ண. இதுவா? இதுதான் நீ கேட்ட அந்த காயின்லெஸ் காயின் டாஸர். ஸோ இது எப்படி வேலை செய்யும் அப்படின்னா,
to turn it on, first we need to flick the switch, then to toss it we need to press this button, and once you press it again it's actually catch. So it's going to either be this side or that side, and it will alternate between these two things, and we just need to guess it correctly. That's all. And which side it will be is completely random.
இந்தா மச்சான் வாங்கிக்கோ. சூப்பர்ரா, க்யூட்டாக இருக்கு மச்சான் பார்க்குறதுக்கு. ஆனு டாஸு கேட்சு. பாருறா, நைஸ். அண்ட் இது என் பாக்கெட்லேயும் வைக்க முடியுது. சொன்ன மாதிரியே செஞ்சுட்ட, வேறு லெவல் மச்சான் நீனு. மச்சான் பாரேன், காயினே இல்லாமல் எனக்கு காயின் டாஸ் பண்ணோம், அதுக்கப்புறமா அதை என் பாக்கெட்டில் வைக்க முடியணும். சரியா? இவ்வளோ தான் மச்சான் சொன்னேன். எவ்வளோ மச்சான்? ஒரு 2000 கொடுத்துருப்பேனா? ஃபுல்லாக ரெடி பண்ணிட்டேன் மச்சான். பார் மச்சான், இது என் பாக்கெட்டில் வைக்க முடியுது, அதுக்கப்புறம் இதை ஹெட்டு டெய்லு டாஸும் பண்ண முடியுது.
First of all, thanks a lot for staying this far. And before asking you guys to subscribe to this channel, I feel like I need to answer a few questions like, what the did I just watch right now? This is so random. Why to toss a coin without a coin? To answer that question, first I need to explain what very random creation is, right? From young age, I love doing art, but I also love doing engineering. So what happens when you put those things together? There's going to be some very random creations, hence the name very random creations. This electronic coin tosser is basically a challenge which I took upon myself to learn about electronics. My background is mechanical engineering. I was interested in learning about electronics. So why not, I thought, I will take a basic mechanical operation like a coin flip and try to make it as an electronic operation. So that's why the first creation is an electronic coin tosser, which you have watched right now. Secondly, you may have a question, what to expect from very random creations, right? If you know channels like Veritasium, Mark Roberts, Smarter Everyday, Stuff Made Here, JVV Create, etc., this channel is more or less going to be the same. I'm going to create some engineering stuff, but I'm also going to make some content, some funny content or some movie content or some content around that product, and I'll try to basically post it in this channel. There is going to be a lot of learnings during each and every creation, and I'm going to share it with you guys. I want to deliver special thanks to two people who helped me in making this first video, which is Kali. He's an electrical engineer and he helped me a lot in making me understand about a lot of electrical stuff and also solving the obstacles which I faced along this project. Secondly, I want to deliver my thanks to the Kaleido, aka Fazil. He is the maestro in making the music behind the intro and the outro of this video. Hey! So if you have stayed this far, thanks a lot for staying this far, and please drop a like down below only if you like this video, and you can have comments like if you have any ideas for any of the random creations, or if you want me to explain more about some parts of this video, or if I was wrong somewhere in this video, please comment down below. Share it with your friends who may enjoy this content, and finally subscribe to this channel if you want to see more of this content. That will help me in making more content, and I'll also know that you are interested in seeing similar contents like this. Until then, see you next time. Bye bye.
A creation created for creators.